Okay guys, so I'm going to show you two examples here that involve the factor theorem and then kind of walk through, talk about some keywords and how we do it to show the factor theorem and whatnot. So in this problem it's asking for, is x minus 2, so is that thing a factor of that polynomial? So to do this, remember the factor theorem says if synthetic division produces a remainder of 0, then we know a factor. So what I'm going to do is I'm going to take the, remember, opposite number. So I'm going to take the opposite number of negative 2, and I'm going to use positive 2. And again, I like to do it this way with the L shape. I know the book does it a different format, whatever. So I notice that I'm not missing anything. If you recall, when you're missing something, you got to fill in a 0 placeholder. So I'm not. So I'm going to bring down my 1, my coefficient. Bring down the 2, bring down the negative 6, and bring down the negative 9. And I'm looking to see what I get here. So we would go through this synthetic division. So remember our first term, I would bring down the first term 1. We multiply diagonally. We add vertically. We multiply diagonally. We add. We multiply, and I see that I get a number 4, and when I subtract or add negative 9 plus 4, I get a value of negative 5. So what I want to do is state my answer to this case. So since the remainder, just write this out, since the remainder did not equal 0, right here, so see the remainder is not 0, then x minus 2 is not a factor. So in order for that to be a factor that we, what we're trying to figure out, it must give me a remainder of a 0, and since it didn't, then I know x minus 2 is not one of those parentheses in my final answer if I was to try to factor this down, because the remainder was not 0. Okay, so that's what the factor theorem pretty much states. All right, that's the first example. All right, guys, so in this example, it's not really a question. It's more of a statement that says, I want you to factor this polynomial given this statement right here. So now we got to go back and kind of think about what this means. It says, okay, well, if I evaluate, right, because I have f of some number, if I evaluate, that number right there must be the remainder. So that means if x equals negative 3 produces an answer of 0, the comma, if x equals negative 3 produces an answer of 0, then that must mean x plus 3 is a factor. Okay, but that's not what it's asking us to do. The question said, I want to factor this polynomial, but you know this piece of information. So what I want to do is synthetic division. So we're going to use this factor theorem to help us with the following problem, and we're going to use the synthetic division to actually do the work. So since negative 3 gives us 0, that means x plus 3 is a factor, so I'm still going to use negative 3. Because x plus 3 is a factor, then I use the opposite number, but here I don't use the opposite number because I'm telling you negative 3 will give you a 0. So I use that number. That number does not change. So I'm going to put my polynomial, my coefficients. I got a 2, we have an 11, we have 18, and we have 9. Matter of fact, you can go ahead and put 0 here because you already know that negative 3 is going to produce a result of 0 for the remainder. So you can go ahead and be confident with this. So we go through and we do synthetic division. I bring down the 2, we multiply, we add vertically, we multiply, we add vertically, we multiply, and no surprise that we get 0 for a remainder. So our answer looks like this now. We know that one parenthesis is x plus 3. Well, then I'm going to take this final result here and I'm going to put that into a polynomial. Well, notice we started with an x to the third. So my answer here is going to start 1 degree less. So this would be 2x squared, then plus 5x, and then plus 3. And notice I'm putting parentheses around this. Because remember, factoring creates parentheses, which in terms creates multiplication. Here is one factor that we already knew. As a matter of fact, we can go ahead and highlight that. And that's going to come from this. We already knew that was a factor because it was given to us. Well, the question at the very top says we need to factor this problem. Well, we've already got that, which means maybe I can factor this. Well, you got to think about it. My first term is a 2x squared, so I'm going to bring down my x plus 3. We know that's part of our answer. So this is going to be 2 parentheses, probably because it's a trinomial. So 2x in the first one, x in the second, or I could flip-flop those two, doesn't matter. And I'm trying to add to get 5, so let's see, 3 and 1. What if I put the 3 there and the 1 there? Everything's positive, so all these signs are positive. And we have now factored our work. This is the factored answer. So I want to bring something to your attention that says the following. We had to factor something that had 1, 2, 3, 4 terms. We don't know how to do factoring by 4 terms yet. However, I gave you a piece of information that was a starter point for help. So using the factor theorem, it says, okay, well, if I take -3 and I evaluate, I get 0. So let me use -3 for synthetic division. Let me go through synthetic division. No surprise that I get 0 at the end. Take the part that I end up with, this polynomial, and factor it down, and notice those pieces, or actually this piece, produces these 2 factors. There's the factor that I already had at the beginning. And remember, when you factor, it creates parentheses, which implies you create multiplication. So, to recap this now, or to summarize this little part, if we multiplied all 3 parentheses out. So if I was to go through and multiply all 3 parentheses out, we should get the following. So if we multiply all 3 of these parentheses out, we should get 2x to the third plus 11x squared plus 18x plus 9. It's supposed to be a 9. Awesome. Guys, factor theorem, just wanted to show you some examples that we're going to get into, and then we're going to pick back on this, or pick back up with graphing, and show you how it all relates. Man, this is super exciting stuff. Peace out.